The role in the invention of the wheel plays a crucial role in the human civilization. One of the important applications in suitcases is rolling on coasters. Rolling wheels makes it easier to carry and luggage. Wheels on the surface move on the through rolling motion. In rolling motion, when a wheel moves on a surface, the point of contact with the surface is always at rest. Since the point of contact is at rest, there is no relative motion between the wheel and the surface. Hence, the frictional force is very less. At the same time, if an object moves without a wheel, there is relative motion between the object and the surface. As a result, frictional force is larger. This makes it difficult to move the object. Ideally, in pure rolling, motion of the point of contact with the surface should be at rest, but in practice it is not so. Due to the elastic nature of the surface at the point of contact, there will be some deformation on the object in this point on the wheel or surface. Due to this deformation, there will be minimal friction between the wheel and the surface. It is called rolling friction. Rolling friction is much smaller than kinetic friction. Methods to reduce friction. Frictional force has both positive and negative effects. In some cases, it is absolutely necessary. Walking is possible because of frictional force. Vehicles, bicycle, car can move forward because of the frictional force between the tire and the road. In the braking system, kinetic friction plays a major role. As we have already seen, the frictional force comes into effect whenever there is a relative motion between two moved surfaces. In big machines used in industries, relative motion between different parts of the machine produces unwanted heat which reduces its efficiency. Ball bearings provides another effective way to reduce the kinetic friction in machines. If ball bearings are fixed between two surfaces during the relative motion, only the rolling friction comes to effect and not the kinetic friction. The rolling friction is much smaller than kinetic friction, hence the machines are protected from wear and tear over the years. During the time of Newton and Galileo, frictional force was considered as one of the natural forces like gravitational force. But in the 20th century, the understanding on atoms, electrons, and protons has changed the perspective. The frictional force is actually the electromagnetic force between the atoms on the two surfaces. Even well-polished surfaces have irregularities on the surface at the microscopic level. When we pedal a bicycle, we try to push the surface backward and the velocity of point of contact in the real wheel is backwards. So the frictional force pushes the real wheel to move forward. But as the front wheel is connected with a rigid support to the back wheel, the forward motion of back wheel pushes the front wheel in the forward direction. So the frictional forces act backward. So remember, both frictional forces corresponding only to static friction and not kinetic friction. If the wheel slips, then the kinetic friction comes into effect. If in addition to static friction, the rolling friction also acts on both the wheels in the backward direction. So consider an object moving on a horizontal surface with a constant velocity. Some external force is applied on the object to keep the object moving with a constant velocity. Force. What is the net force acting on the object? If an object moves with a constant velocity, then it has no acceleration. According to Newton's second law, there is no net force acting on the object. The external force is balanced by the kinetic friction. It is not that no force acts on the object. In fact, there are two forces acting on the object. Only the net force acting on the object is zero. It is also important to know how to apply Newton's laws to circular motion. Circular motion is very one common type. So particle can be linear motion with or without external force. When circular motion occurs, there must be necessary some force acting on the object. There is no Newton's first law for circular motion. In other words, without a force, circular motion cannot occur in nature. A force can change the velocity of a particle in three different ways. The magnitude of the velocity can be changed without changing the direction of the velocity.